I'm going to do another example about the same calculations. And in this case, it's going to be about barium sulfate. I'll say barium sulfate is sparingly soluble in water. If its solubility product is 1.08 exponent negative 10 mole squared dm negative 6 at 25 degrees Celsius, calculate the mass of barium sulfate that should be added to the saturated, so this should be barium nitrate. Calculate the mass of barium nitrate that should be added to a saturated solution of barium sulfate. Common ion effects is being investigated here. In order to reduce the concentration of sulfate ions to a third the original value. To a third the original value. This is a very good question. If the solubility product of barium sulfate is that at 25, calculate the mass of barium nitrate that should be added to a saturated solution of barium sulfate in order to reduce the concentration to a third the original value. Now here we need to get that original value they are talking about. What is that original value? In other words, we need to get the original concentration of barium of sulfate ions before we added barium nitrate. We are aware that barium sulfate is sparingly soluble. Give us barium ions and sulfate ions. So Ksp here is equal to concentration of barium ions, concentration of sulfate ions. So this is what we need to get. We are given this, we have the Ksp, we don't have this, but we need to make sure that everything is in one given letter, so that that's why we are going to let, as I've told you, relate the molar concentration of barium sulfate, let the solubility, or you say let the molar concentration of barium sulfate equal to Y moles per liter. So if it is Y moles per liter, according to this equation, each of these is Y. Not so?
Yes, teacher.
That will imply that our Ksp, which is 1.08 times 10 power negative 10 is equal to Y squared, such that your Y is equal to 1.0810 exponent negative 10 square root. And the square root of that value is The square root of that value must be, which value must it be? You try to press your calculators and tell me the answer. Is it 1.039 exponent negative 5?
Yes, teacher.
Moles per liter. So that's the original concentration of the sulfate ions, by the way. Because if this is Y, this is Y, this is Y. So we shall say concentration of sulfate ion is original is equal to Y is equal to the same value. Now, concentration of sulfate ion is new, which they are talking about, is a third that value. So this one gives us which answer? 3.463 exponent negative 6 molar. So that's the new sulfate ion concentration. We have already now done this. This is the new sulfate ion concentration. Now we want the mass of barium nitrate. That should be added to the saturation solution of barium sulfate to reduce that concentration to that value. Now the actual mathematics, or the serious mathematics, begins. So what are we going to do? To get the mass of barium nitrate, we cannot get that mass without knowing its concentration. Are we together? Because we need the concentration which we shall convert to mass using RFM. Are you getting me? And we do the same thing for common ion effect. So we shall say, let the molar concentration of barium nitrate equal to X moles per liter. That's what it should be, X moles per liter. So what shall we have? Remember, this is treated as common ion effect. I've already done an example about calculations involving common ion effect. Being a strong electrolyte, it gives us barium ions. It completely ionizes to give us barium ions and nitrate ions, two of them. So if its concentration is X molar, this will be X molar, this will be 2X molar. Now that of the barium sulfates, its equation is this: barium ions plus sulfate ions. So the trick is here. We have already got this new here, which is 3.463 negative 6, isn't it?
Yes, teacher.
If it is that, we also have that of the barium ions according to molar ratio. That of the barium ions will be the same. Muhammad, are you getting me?
Yes, teacher.
Treatment of common ion effect now comes in here. Can I proceed?
Yes, teacher.
What did we do in common ion effect? We said we look for the common ion effect and look for its effective concentration. So the concentration of barium ions here is likely to be X plus 3.463 exponent negative 6. That's what it's likely to be. But since this is a strong electrolyte, then we know that this concentration here is very small. Maria, are you getting me?
Yes, teacher.
This is very small compared to X because barium sulfate is sparingly soluble. It gives us a very small concentration of barium ions. So, but 3.463 exponent negative 6 is very small as compared, you must take that assumption, as compared to X, which implies that the concentration of barium ions is approximately equal to X moles per liter. Are we together? This one's taken to be negligible, and we take that from the completely ionized strong electrolyte. You see how we are almost getting the mass we are aiming at. So now we rewrite our expression for KSP, which is KSP is equal to concentration of barium ions, concentration of sulfate ions, which is equal to Xc into, what is that of the sulfate ions? It is this one. Are we together?
Yes, teacher.
It is 3.463 exponent negative 10. This one is equal to, I think we have the KSP with us. Our KSP is 1.08 exponent negative 10. 1.08 negative 10. A very good question. So X here is 1.08 exponent negative 10 over 3.463 exponent negative 10. What is our answer? By the way, this is negative 3. Students are not following, they are not in class. Students are not in class. This is negative 3, and this is also negative 3. So our answer is it negative 3, negative 6? It's negative 6. It's negative 6. It's negative 6. Negative 6 according to my calculation here. This value here for the sulfate ion. The barium ion, we get its effective concentration and take an assumption. So my X here, if I work out with this will give me negative 10 minus negative 6, that's negative 4. When you divide this, your answer is likely to be 3.119 exponent negative 5 molar. So that is the concentration of barium nitrate. Its molar mass is, molar mass of barium nitrate. Remember, the question wants us to get the mass that must be added. It's a lengthy question, but it is, I've liked it. It says 3 concepts. The first concept, do you know how to use KSP to get concentration? The second concept, do you know how to apply common ion effect? The second question, do you know how to convert moles to mass for compound to be added in order to precipitate a given compound? So this one is molar mass of barium nitrate, which is, barium is 137. Then nitrogen is 14. times 2, which is 28. Oxygen is 3 times 2, which is 6 times 16. This will give us the total mass as 261 grams. So mass that must be added, mass of barium nitrate will equal to 261 times 3.119 exponent -5. That gives me 0.008 grams. Do we need another example? I think I can do one more last example and then we make it, we call it a lesson. But why don't we stop here?
We stop, teacher.
Yeah, this should be the end. So